Hi, kiddos. Today we're going to move on to notes number 26, which is about proportions, similar figures, and scale factor. So let us begin with ratio. What is a ratio? Well, it shows the relative sizes of two or more values. So, for example, a classroom has 16 boys and 12 girls. Now, this ratio can be written as three different ways. We can write it as such, 16 colon 12. We can write it as a fraction, 16 over 12, or we can actually write out 16 to 12. Ratios are generally written in the lowest term. So notice if we have that fraction 16 over 12, you would actually need to reduce that, and you would get 4 over 3. Ratios can compare two unlike things. So, for example, let's say we have that Joe earned $40 in 5 hours. We can set up our ratio with dollars over hours, which would mean we're talking about 40 over 5 hours. If we reduce that, because we need to be in its simplest terms, we would reduce that to 8 over 1, which basically means that we make $8 in 1 hour. Okay, now there's a special name for this type of ratio because the denominator is 1, and we call that a unit rate. Ratios can be broken down into two different ways. They can be part to a part. So, for example, girls to boys, which if we did a ratio of girls to boys, we would have 12 over 16. And if we reduce that, you would have 3 girls over 4 boys. And ratios can also be written as a part to a whole, okay? So we got to do a little bit more math work there. We'd have to add up 12 plus 16 to figure out what all the total number of students essentially is. So we would have a fraction for girls overall to be 12 over 28. And when we reduce that, we would get 3 girls over 7 all. And then you can also have the other part to whole would be the boys overall. And the boys overall ratio would be 16 over 28. And when we reduce that, you'd get 4 boys over 7 all. Okay? If a ratio is part to whole, then you can actually divide and find a decimal or a percent. That would be the part divided by the whole. So if we were to analyze the girls first, and you have 3 over 7, which was the simplest form, and you actually put that in your calculator, 3 divided by 7, and you move the decimal over 2 places, you get 42.9%. And for the boys, we had 4 over 7 as that ratio. And if we were to divide those values, you'd end up with 57.1%. And guess what happens if you add up these two values? Yep, they give you 100%. All right, so in our first example, use the number line below to determine the ratio of BC to GK. So we've got to find BC and GK and then set up our ratio. First thing we need to notice on this number line is that it is going by tens, okay? So from B to C, that would be an increment of 10. G to K would be 10, 20, 30, 40. So our ratio would be 10 over 40, which if we reduce that would be 1 over 4. Next example, the two triangles are similar. Label the size and ratio form that corresponds to each other. Now, if you need to, you may want to redraw the two triangles so they actually line up perfectly. So this would be C, that is B, that's A. Just so it makes it a little bit easier so that when we label our sides, we can get them correct. Now, there's obviously 3 sides to a triangle, so I should have 3 sides that I'm comparing. First one, let's go with ED. ED would go to BC. Then next side would be DF. And DF would match with CA. And last but not least, EF would match up with BA. All right. All right, next vocabulary word is proportion. This should be something you're familiar with, should have seen it back in your younger days. So proportion is basically when you have 2 ratios that are equal, okay? When we solve proportions, we like to cross multiply, all right? Or as I like to say it, it's like you're doing the butterfly. See, so beautiful. So let's look at proportion equivalence. So how many different ways can we write out a situation if we have these 2 values that we're cross multiplying? So we can have A3 equals 2B. You can have 3A equals 2B. You could have 2B equals 3A. Hopefully you're seeing the point here that biggest thing is that the A and the 3 match up together always, and the 2 and the B always match up together. But notice they can be on any side of the equal sign as long as those match up. You can pretty much write it any other way. So, an example. In an election, Damon got 3 votes for each 2 votes that Shannon got. Damon got 72 votes. How many votes did Shannon get? So our ratio we're going to set up is going to be Damon to Shannon. So in the first example, right here, we know that Damon got 3 votes and Shannon got 2 votes. We're setting up a proportion, so equals. Now, in the second part of this problem, we know Damon got 72 votes, but we have no idea how many votes Shannon got. So that's our proportion setup. All right, so now we're just going to simply cross multiply. So 3 times x is 3x. 2 times 72 gives you 144. Solving for x, so we're going to divide by 3. And we get x to be 48 votes for Shannon. All right. So examples 2, 3, and 4 are on your own, or on your own, I should say. Example 2, I want you to set up your ratio of tires over money cost. Okay. Example 3 and 4 are pretty algebraic. Key here is making sure that you remember to do things as distribute, which you'll have to distribute that 10 to the x plus 5. Okay. And over here in example 4, you may want to make sure you, order of operations, you go ahead and add that 15, or combine like terms, I should say, 15 plus 25 before you cross multiply. And you can see that you'd have another distribution situation over there too. Okay, so we're going to jump down to number 5, aka 5. 3 cans of soup cost $5. How much will 12 cans cost? So we got number of cans over cost, which is our ratio setup. So in the first part of this problem, we have 3 cans over $5. That's going to be equal to, we want to get 12 cans, and we're not sure how much that costs. So now when we cross multiply, we get 3 times x, which is 3x, times 5 times 12, which is 60. Going to solve for x by dividing both sides by 3, and you end up with x equals 20, and that's $20. Holla, holla. All right, so when 2 ratios are equal, we say that they are proportional. All right, so we're going to reduce the ratios in each proportion below to see that they are proportional. So if you have 120 miles divided by 2 hours, you get 60, right? Now what we're hoping, if these are proportional, is that this other side is also going to be 60. So 180 miles divided by 3 hours, yep, is also 60. So check mark, these are proportional. Let's check number 2. New old, this is already wording for scale factor. Fun fact. So if you got 10 over 12 and you reduce that fraction, you get 5 over 6. So if we reduce 15 over 18, the hope is we also get 5 over 6, and that is true. So check, it is proportional to. All right, another vocabulary word, similarity. Notice this is the symbol for similarity, okay? It's just the squiggle. So if you remember congruent symbol, just the squiggle here, just that part is similarity, okay? So similarity is when you have two figures that have the same shape and their only difference is their size. So basically enlarge or reduce. So you can see that here with these two triangles, same exact shape. One is just smaller than the other. Two figures that have the same shape, their corresponding sides are proportional, and their corresponding angles are congruent, then those two figures are, in fact, similar. Now, there is a difference between similar and congruent. Make sure you are aware of that. All right, so two triangles are similar if and only if, and by conditional, their three corresponding angle pairs are congruent and the measures of their three corresponding sides are proportional. Okay, we'll be using scale factor. Okay, so there's a vocab word to help determine proportionality as well. Or when you find proportionality, that ratio that you're actually looking for is known as the scale factor. Okay, it's so the definition for scale factor is the number you multiply by to enlarge or shrink a figure. SF, this is the shorthand version of scale factor, just so you're aware. And when you're looking for scale factor, you're always going to compare the new to the original, aka the old one. All right. So if you want to make a shape larger, so you want to enlarge it, you need to multiply it by a number greater than 1. So in this example, let's say the scale factor is 2. All I'd have to do here, so please write this in, this is going to be given, all right? All we have to do is take each one of those sides, 3, the 4, and the 5, and simply multiply it by the scale factor, which is 2. So in doing so, we get new sides, our enlarged triangle would be 6, 8, and 10. So now let's say you instead want to make a shape smaller, reduce it, shrink it. You multiply by a fraction smaller than 1. And notice it has to be a fraction, and it's important that it's smaller than 1 because 3 over 2, think about it, is not smaller than 1, so that would actually be an enlargement, not a reduction, okay, or a shrinkage. All right, so please be careful. Just because it's a fraction, you need to make sure that it's a fraction that's smaller than the number 1. Okay, so please write these values in here. We have a rectangle, and we're given that one side is 9, and the other side is 12, and we're going to use the scale factor of 1/3. So we're going to take the original value, okay, 12, and the original value of 9, and we're going to multiply it by our scale factor, which is 1/3. So 12 times 1/3, 9 times 1/3. 12 times 1/3 gives us 4. And 9 times 1/3 gives you a value of 3. All right. hopefully if you haven't already noticed, if your scale factor is 1, it actually is the number 1, then note that nothing would change between the two figures. All right, now let's say if you're looking for the scale factor. So both figures, you have all your values, but you need to figure out what is a scale factor. Well, all you gotta do is create a ratio of new over the original. Typically, unless stated, usually the first one is always going to be your original or the old one, okay? And the second one is the one that you're comparing it to, so that would be your new one, okay? So we're going to set up 3 ratios, because remember, you have to make sure that all 3 sides are proportional in order for to say that these are similar. So new over old, and I've already deemed this bigger triangle as the new one. So I'm going to set up my first ratio as 6 over 2. Got 12 over 4 and 9 over 3. Now, if they're in fact proportional, which would mean that they're similar, I should get the same value when I reduce these values. Okay, if I don't, if one of them does not work out, then these two triangles are in fact not similar. 6 divided by 2 gives me 3. 12 divided by 4 gives me 3. 9 divided by 3 gives me 3. Check, check, check. All 3 values are the same. All 3 answers are the same. So, therefore, these 2 triangles are similar because their sides are proportional, and the scale factor is 3. Now let's look at another situation. Okay, notice the only difference now is I've switched which one's the new one and which one's the original. Okay, so that does change your order in your ratio here. So this is why it's important to always identify which one's the original, okay, and which one's the new. So in this case, we would have 2 over 6, 4 over 12, and 3 over 9. When I simplify these fractions, hopefully I get the same thing. I get 1/3, 1/3, and 1/3. Check, check, check. Scale factor is 1/3, and these 2 triangles are in fact similar. All right, so we have 3 different ways of proving triangles to be similar. Some of these may be familiar already to you guys, okay? Angle-angle similarity is one. We have side-side similarity and side-angle-side similarity. Please know, angle-angle does not work for proving congruent. Side-side-side does work to prove congruent, and side-angle-side does also work to prove congruent. Okay? So side-side-side and side-angle-side can go both ways. Basically, they can go for similar and they can go from congruence. Angle-angle only works for similarity. Okay? So, what does angle-angle state? If 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. Note, if 2 angle pairs are congruent, then the third angle pair must be congruent. So, angle B here would match up with angle X, just going based off the markings, and angle C would be congruent to angle C is congruent to angle Z. All right, now let's look at side-side-side similarity. If all 3 corresponding sides between 2 triangles are proportional, okay, meaning they can be multiplied by the same scale factor, then the 2 triangles are similar. Remember, your scale factor is new over original. So we have 2 triangles here. This is my original. This is the new. This is saying that these 2 triangles are similar. So let's check that. We're going to compare or set up the ratio. And when we do that, it's new over old. So 8 over 4, 18 over 9, and 12 over 6. When I reduce those, all 3 of them should give me the same value. You notice I get 2, I get 2, and I get 2. So the scale factor is 2. So yes, those 2 triangles are in fact similar. Then we have side, angle, side. If the corresponding sides of 2 triangles are proportional and the included angles are congruent, then the triangles are similar. Okay? So we can already see that angle X is included between those two sides, and angle A is included between those two sides, and they're marked as congruent. So now all we have to check is proportionality of the sides, comparing the new to the old. So you'd have 10 over 5 and 16 over 8. When you reduce both of those fractions, you get the same number, which is 2. So the scale factor is 2. Alright, so these next examples, we are going to determine if the following triangles are in fact similar. Okay? If they're similar, we're going to state whether it is because of angle, side, or side. And we're going to make a similarity statement. Okay? So, first thing, I noticed a few little typos here. We don't have a triangle ARU there, so I'm just going to squiggle that out. Okay? And on the second one, we don't have a triangle XYZ, so I'm going to scribble that out. And if you already noticed, change that 15 to a 16. All right, now let's get to work. Clearly we can see that we do have already one angle and both triangles marked as congruent, angle H and angle X. Can I find anything else? Hopefully you're saying yes, and that's these two angles here. I can mark those angles as congruent because of vertical angles. So, you have enough information to distinguish that these two triangles are in fact similar. Hopefully you said yes. The reason why? Angle. So, the similarity statement would be that triangle H, Y, J, order matters, is similar to triangle X, Y, C. All right, let's look at the next one. Notice I'm not given any angles, so 2 of the 3 options aren't going to work. So now we're really resulting down to this being side to side. Now, in order for it to be side, we have to check proportionality. So this is the old, this is the new. When we set up our ratio here, it's new over old. So we would have 12 over 8, 9 over 6, and 16 over 10. All right, when we reduce them, we get 3 over 2. Yes, 3 over 2. And, 8 over 5. Well, that's no bueno. So because that one didn't work, this would be, no, these two triangles then would not be similar. All right, looking at our next example. So we're looking at triangle TPJ, so this little bitty triangle here, and then looking at the bigger triangle ATN. So I'm actually going to redraw the smaller one, or, let me redraw the bigger one. Okay, so let's redraw the big triangle. Okay, so that's A, that's T, and that's N. And I know that's 55. And I know that's 75. Okay. So basically what I did was I just got rid of this bottom half for that picture. Okay. That's what we're looking at. So trying to see if we have anything in common. All right. We see that we have two angles in, one angle in common. This one here is 50, but this one here is 55. So because they don't match up, they're not congruent, this would be a no. So I can't do anything else. Number 10. What do you know? It's an OYO problem. All right, now let's switch it up a little bit. Given that the following triangles are similar, so we're telling you that these two triangles are similar, use proportions to solve for the unknown segment. So if triangle ABC is similar to triangle XYZ, find X. So they've already gave me the hint. We're going to be using proportions here. Now your proportions are going to be set up like those scale factors, new over old. So that's old that's new. So when you get to this one over here, that's old, that's new. All right, so let's set up our proportion then. We would have 10 over 6 equal to 25 over x. I'm going to cross multiply, do the butterfly, and you get 10 times x is 10x. 6 times 25 is 150. We're going to divide both sides by 10. And we get that x equals 15. All right, if you hadn't already read, 12 is an OYO problem. I've already identified which one's the original and which one is the new. You guys can handle it. Adios. Ciao.